to be mutually exclusive or not to be mutually exclusive. With probability, that is sometimes the question. Keep watching. Welcome to Math Bytes, I'm Allison, and today we're talking about addition rules for probability. Now, it's important to know whether your events are mutually exclusive or not. So let's take a look at this. If events A and B are mutually exclusive, then the probability of A or B is equal to the probability of A plus the probability of B. If events A and B are non-mutually exclusive, then the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Okay, does this seem confusing? Let's do a couple of examples and let's find out what mutually exclusive and non-mutually exclusive events actually are. Let's take a look at an example. You roll a single six-sided die. What is the probability that you'll roll a 5 or an even number? All right, the first thing we have to do is decide whether or not these events are mutually exclusive. So ask yourself, can these events occur at the same time? Could you roll a 5 and an even number? No, you couldn't, not with a single roll. A 5 is an odd number, so there's no way that these two things can happen at the same time. Therefore, these events are mutually exclusive. So we'll remember that the probability of A or B is equal to the probability of A plus the probability of B for mutually exclusive events. And in this case, that means that the probability of rolling a 5 or an even number is equal to the probability of rolling a 5 plus the probability of rolling an even number. Okay, so what's the probability of rolling a 5? All right, in our denominator, we put how many options we have. So it's a six-sided die, the numbers 1 through 6, so there's 6 possible outcomes total. So the denominator is 6. How many of those outcomes are a 5? Just one, only one face on the die has a 5, so the probability of rolling a 5 is 1 over 6. What's the probability of rolling an even number? All right, denominator is still 6. We have 6 total possible outcomes. How many of those outcomes are even? 2, 4, or 6. 3 of them. So the probability of rolling an even number is 3 over 6. And now I just add them up. 1/6 plus 3/6 is equal to 4 over 6, and I reduce that, and that is equal to 2/3. Let's do another example. You roll the same six-sided die, but now you want to find out the probability of rolling a 5 or an odd number. So same thing, let's figure out whether or not these events are mutually exclusive. Could these events occur at the same time? Could you roll a 5 and an odd number? Yes, you could. If you rolled a 5, that's also an odd number, so that would satisfy both criteria. So because these two events could occur at the same time, they are non-mutually exclusive. So we'll remember that the probability of A or B in this case is equal to the probability of A plus the probability of B minus the probability of A and B. So we have that the probability of rolling a 5 or an odd number is equal to the probability of rolling a 5 plus the probability of rolling an odd number minus the probability of rolling a 5 and an odd number. Okay, so what's the probability of rolling a 5? It's 1 over 6. What's the probability of rolling an odd number? The denominator will be 6. We have 6 total possible outcomes. How many of those outcomes are odd? 1, 3, or 5? 3 of them are odd, so the probability of rolling an odd number is 3 over 6. Now, what's the probability of rolling a 5 and an odd number? How many ways are there to do that? There's just one. If you roll a 5, that's also an odd number, so that satisfies the criteria. So the probability of rolling a 5 and an odd number is 1 over 6. Now we just do the arithmetic. So we have 1/6 plus 3/6, that is 4/6, minus 1/6, that's equal to 3/6 or 1/2. So in this case, the probability is equal to 1/2. Now, subtracting out that probability of rolling a 5 and an odd number keeps you from double counting that outcome. If you didn't do that, you'd be counting rolling a 5 twice. Okay, let's go through another example. A single card is drawn from a standard 52 card deck. And we want to figure out, first of all, what is the probability of drawing an ace or a king? And then, what is the probability of drawing an ace or a heart? All right, so let's look at the probability of drawing an ace or a king first. Again, we ask, are these events mutually exclusive? Could you draw, with a single draw from the deck, an ace and a king at the same time? No, you could not. If you do a single draw, you might get an ace or you might get a king, but you can't get both. So these events are mutually exclusive. So the probability of drawing an ace or a king is equal to the probability of drawing an ace plus the probability of drawing a king. Now, what's the probability of drawing an ace? All right, our denominator is how many total possible outcomes we have. There are 52 cards in the deck, so our denominator is 52. How many of them are aces? 4 of them are aces. So the probability of drawing an ace is 4 over 52. What's the probability of drawing a king? Again, denominator is 52. That's the total number of possible outcomes. How many of those outcomes are kings? 4 again. So 4 over 52 is also the probability of drawing a king. We add these together, we get 8 over 52. And reducing, we find the probability is 2 over 13. Okay, now let's find the probability of drawing an ace or a heart. Again, we have to determine whether or not these events are mutually exclusive. So ask yourself, could they occur at the same time? Could you draw, with a single draw, an ace and a heart? Yes, you could. You could draw the ace of hearts, and that would satisfy both criteria. So these events are non-mutually exclusive. They could happen at the same time. So the probability of drawing an ace or a heart is equal to the probability of drawing an ace plus the probability of drawing a heart minus the probability of drawing an ace and a heart. All right, what's the probability of drawing an ace? It's 4 over 52. 4 aces in the deck, 52 cards total. What's the probability of drawing a heart? 52 is in the denominator still because I have 52 cards in the deck. How many of them are hearts? 13. There's 13 of every suit. So 13 over 52 is the probability of drawing a heart. What's the probability of drawing an ace and a heart? How many ways are there to do that? There's only one. There's one ace of hearts, and that's the only card that would satisfy both of those criteria. So the probability of drawing an ace and a heart is 1 over 52. So now we do the arithmetic, and we have 4 over 52 plus 13 over 52 is 17 over 52 minus 1 over 52 is 16 over 52, and that reduces to 4 over 13. So in this case, the probability is 4 over 13. To use the addition rules for probability, always ask yourself, are these events mutually exclusive or not? If they can occur at the same time, they are not mutually exclusive. That's it for this episode of Math Bytes. If you like our videos, you should subscribe to our channel. And if there's something you'd like to ask us, just send us an email. We're at contactmathbytes@gmail.com, and I will see you next time.